Hi, good day, everyone. Welcome to our webinar. Thank you for joining. Today is the first in our concrete hit prevention webinar series titled Avoid Damage Efficiently Using Stepped Frequency Continuous Wave Ground Penetrating Radar. We're very happy to have our main speaker, Dr. Michael Arvanitis, who is the Screening Eagle Head of Product Strategy and Marketing GPR. Myself, Maria Felice, I'm the Product Marketing Manager for the APAC region. And we also have Mr. Hussam El Ghanami as a panelist, who is the Head of Product Management for Infrastructure. So before we start the webinar, I'll just be launching a small, very brief poll, just to get an understanding of what sector you're all from, and this will hopefully help us to plan more appropriate webinars about topics which interest you in the future. So please just take a second to let us know what sector you work in. So a brief company introduction, Screening Eagle Technologies. We were founded in 2019 with the merger of two companies, Prosec, which is a leading NDT manufacturer since 1954, headquartered in Switzerland, and DreamLab, which is a software and robotics company founded here in Singapore in 2015. So Screening Eagle Technologies is a global company with over 280 employees in 8 country offices around the world. Here in Singapore, we have a sales and service office and also a very large R&D department. And we're supported by over 200 partners across the region. So trying in one slide to share with you what we do. So we provide sensors for non-destructive testing for a wide range of sectors. So this includes industrial, road inspection, concrete inspection, which we'll be talking about today, geomatics, and metal. So you can see at the top, those are the hardware, the sensors which we manufacture. And in recent years, we've paid a lot of attention to software, which is coupled with this hardware to provide a full solution. And this software includes visualization software and also workflow management software. So the focus today will be on concrete, specifically our GPR products for concrete. We also have a GPR product in the geomatics sphere, which does utility mapping, geophysical investigation, and so on. But this will not be something we will cover today. So now I'll pass over to Dr. Michael Arvanitis for the lecture on SFCW GPR for hit prevention.
Thank you very much, Maria. A very warm welcome to all of you. Thank you for joining us. So let me share my screen and we can start our presentation. So why do we really need to do concrete inspections? That's a very, let's say, fundamental question that we have to ask ourselves. The main reason is that every year we have about 22 billion of tons of new concrete that are being poured around the world. So that's a big number. And out of this number, there are about 50 billion holes that need to be drilled. Why? Either for maintenance reasons or for expansion or for any repairs that need to be done to the concrete structure. So drilling a hole in concrete is never and was never easy. So you need to be very careful not to hit fundamental structure inside the concrete. So that's why, and that's where actually GPR is coming to help you with that. Because if you just make even the tiniest mistake on the field and you hit, one wrong drill, then that's enough to cause a very costly damage to the building, to the structure that you manage, and can be very catastrophic for all. So what we are actually suggesting, we are suggesting to use ground penetrating radar before you drill or you're planning to drill a hole into your concrete. And we have 3 different hardware units that are combined with unique software and a whole ecosystem of platform that can actually help you with your on-site needs. So what you see on the left side of the slide is a GP8000. It's our workhorse ground penetrating radar that's being used to scan large areas for inside concrete. And the way we do that is that we have our ground penetrating radar. It's run by an iPad, so you can see the screen, and you scan and mark rebars. So you just push or pull your equipment, you see the rebars on the screen, and then you mark on where the rebars are. We do that in two directions, just to make sure that we actually see every single target, no matter where the target is, if it's perpendicular or in parallel to the direction that we are moving the ground penetrating radar. And then as soon as you have a small, let's say, tomography of the area that you would like to scan, then you don't need to worry anymore, because you are absolutely sure that the area that you're going to drill the hole is clear. So you can dig deep, like the video that we see over here on the right side of the screen, and you can take the core from the concrete and so on. So let's see the differences between the ground penetrating radars that exist in the market right now. We have two different, let's say, flavors of ground penetrating radars. One is the old technology of pulse ground penetrating radar, where you have a system that's very dependent on the frequency of the antenna that you're buying. So you have different frequencies in the market. You select a specific sender frequency, and then based on that frequency, you have certain limitations on either the depth of the penetration or the resolution of your ground penetrating radar. The thumb of the rule of thumb over here is that the lower the frequency it is, the deeper you penetrate, and also the lower the frequency it is, the worse the resolution that you get. So if you need to find, let's say, big targets, you need to go, if you need to find, let's say, deep targets, you need to go with a lower frequency. But the problem in this case is that the lower the frequency is, the resolution gets worse and worse. That means you need bigger targets in order for this to be detected. So this is what we call the frequency dilemma. And this is where we, as Screening Eagle Technologies, give an answer to this dilemma by introducing this technology, the step frequency continuous wave. So if you compare the SFCW to the pulse system, then in our technology, you don't really face the frequency dilemma, because what you have in your antenna is a very ultra wideband antenna that can cover a wide range of frequencies from about, let's say, 200 megahertz up to around 4 gigahertz. And so you can see also deep enough, like here, but also you can see small targets like rebars or small cables inside the concrete and so on. And we have introduced into the market 3 different, let's say, flavors of our ground penetrating radar, depending on the needs of your survey. So if you have, let's say, a tunnel survey, you can use the GP8000. If you have areas that need to be, that are tight and you don't have enough space, you can use the GP8800. Or if you have large areas and you need to scan them with one pass, you can use the GP8100. So let's see the differences between those 3. You can see the 3 different systems over here, okay? All these are communicating wirelessly with an iPad, and you can see the data in different forms, which is very helpful if you're on the field. So you can see either the full radar version if you're an experienced user. You can see a migrated version of the targets where the hyperbolas are being removed. You can see a 2D tomography or a 3D tomography. And this is very unique to what we are offering, because no other manufacturer in the market right now can offer this type of visualization and also this type of ecosystem. So let's discuss in detail about each of these three different systems and what they offer. So let's start first with the smallest in size. The smallest in size is the GP8800. It's a very small factor antenna that carries a GPR inside it, okay? And it's very good for small and congested areas, or it's very good for curved surfaces. So if you have a curved surface, you can't really go with a typical ground penetrating radar because it can't really see the whole surface, okay? But this antenna is ideal for this, and it comes at a handy size, and it gives a very good resolution of the targets that you're looking at. Then in the middle, we have the middle size ground penetrating radar. It's the GP8000. It used to be our first one in the series. So this one can give you deep and clear data down to about 60 centimeters in depth penetration, which is more than enough when it comes to concrete application. It has excellent ergonomics, and you can use it for many different applications, even for bridges or roads or tunnels. So you can use this one. And it's very good for long line scans. So if you have a very long line, you can use the GP8000 just to scan this line. Then, last but not least, we have the newest addition to our series, the GP8100. So this is perfect if you have large areas, if you need to scan areas quite fast, and if you want to take 2D tomography pictures directly on your screen. So based on the needs that you have on the field, you can select the right solution for you. So all this is being supported by our powerful software. So as I said before, you can see the radargram over here. You can see the targets at different shapes and sizes. So over here, it's a typical non-migrated radar form. Over here is the migrated, where we remove the hyperbolas, the 2D tomography, the 3D tomography, and of course, you can also play that on augmented reality on the side so people can see exactly where the targets are and get a clear picture of what's happening beneath. I have included some examples to show you with different units that I have collected. So this is data with the GP8000. So you can see very high quality in both 2D and 3D, and you get quite good versatility. So I will stand a bit on this radargram over here on the left side. I don't know how experienced you are, but typically when we collect data, the first picture that we get from the subsurface looks like that, okay? So what you see over here is the a small, let's say tomography, a small picture of what's happening beneath the concrete. And you can see different targets that have different amplitude, okay? Some are metallic targets and some are not metallic targets. I can get information about their depth. I can get information about whether the targets are filled in with something or if they're empty, if there are pipes. I can get information about the concrete bottom, which is this one over here. And I can get information about the thickness of the cover, which is this thing over here. And then when I'm done, if I collect several 2D lines, I can create a 3D picture and augmented reality and augment it on the real target that I need to actually drill the hole. So this is the some pictures from the GP8000 on action. So you can see how people are using it. They are having the iPad and they can see how the subsurface looks like this one over here. They can scan ceilings like this one over here, or they can check walls and floors and so on. So you can scan almost everything with the GP8000. Now I have collected some data with the GP8800, and this is data collected from a very curved surface. If I had any other GPR, I couldn't really collect data because the GPR antenna would not really couple with the concrete. But the GP8800 is made for this type of applications. So I can see data like this one over here, and this one over here, and this one over here. These are targets. So when I find the targets and I know what type of targets these are, I can select where and how deep I can drill inside my concrete, which is very important. Of course, I can get some other information like the lamination or corrosion that I may have. I can see also voids inside concrete and many other information that's relevant to my work on the site. These are different pictures from the GP8800. You can see how close it can go to the target. That's very important. You can get very close to the target. You can see very close to a net, so you can collect data close to a nets, and you can go in very narrow places like this one over here. Or if you need more flexibility, you can remove the battery and you can go to even more narrow places and collect data from there. This is a very nice example. Excuse me. This is a very nice example from data collected with the GP8100. So this is really nice because with a single pass, I can collect 2D tomography pictures like this one. So you don't have to make grids anymore. You just go with your GP8100, collect a few lines, and then you get this tomographic picture, which you can augment on the wall or on the floor, on the concrete surface that you are looking to drill the hole. And then when it's safe, when you have identified safe areas to drill, you can go and drill without the fear of hitting something critical in the structure. So that's the part from my side right now. I forgot to mention that you can type in your questions, and then at a later stage, just before we wrap up, we can answer all of your questions. So feel free to write your questions. So I'll pass that to Maria to discuss a bit more about the case studies of the ground penetrating radar. So Maria, the floor is yours.
Thank you very much, Michael. So after that introduction, an explanation of our GPR solutions, I'll now present some case studies which were collected here in Asia on using the SFCW GPR specifically for hit prevention. However, before I share the case studies, I'd just like to bring your attention to this best practice guide from the US CSDA. So that's the Concrete Sawing and Drilling Association. So this is a document which is free to download from the website, and it gives some really good advice and information on using GPR for hit prevention, including what you can detect, practical considerations, limitations, and so on. So the first example that I'll show is from a post-tension slab. So when a slab has post-tension cables in it, it adds further complexity to the hit prevention challenge, because as well as the rebar, we have the post-tension cables, which can sometimes be hidden underneath. And also, it's obviously extremely important that we don't damage these at all, because they will compromise the safety of the structure. So in the first video here, we can see the GP8100 array being used. And here we're just doing a line scan. So the benefit of having an array like the GP8100 is that even if we just do a line scan, we actually can get a top view or a C-scan view of our slab. And this is because the GP8100 consists of multiple antennas. So just very quickly, without doing a grid, just doing a line scan, we can still get the top view, as you can see there. And then for further analysis, as you can see in the lower half of the screen, we can actually get the typical cross-section to understand the positions of the objects. So here you can see rebar towards the top of the slab and the PT duct beneath it. And also, in the top view, as you will see in the remainder of the video, we can actually choose which depth to focus at. So if you have an idea of where your PT is, you can actually focus just on that depth. So you can see here, now we see very clearly just the PT cables themselves. So the next example is still a PT slab and also using GPA 1100, but now we're going to do a grid scan. And you can see once again, despite having to scan in 2 dimensions, very quickly, here we have the resulting image. So you can see this is the large area that was scanned. Here's a top view with the augmented reality function. So this means that instead of only relying on the physical marking on the concrete, we also have this representation which is saved on the iPad and which can be viewed with the augmented reality function so that we can actually see where our results are corresponding to the physical environment. And this is the 2D or C-scan view, and we can also have a 3D view as shown here, and we can use different colors to differentiate between the different objects. So the next example is from a box girder. So this is quite a complex geometry. And what added complexity or the challenge to this hit prevention job was that the concrete had been cast quite recently, so it was still a bit moist. And anchor drilling needed to be performed into this box girder. So obviously very important that the drilling was quite deep, but very important not to hit anything. So the GPA 1100 array was used to perform a quick area scan, as you can see in the video here. Due to the size of the array, only a couple of passes are needed to cover the 60 millimeter by 60 millimeter area. And you can see straight away there on the iPad, we get the image of what's inside the concrete. And because of using SFCW technology, which Michael explained, the depth penetration was still good, despite the moisture in the concrete. So there you can see straight away a really good 3D image generated with just a few passes with the GPA 1100 array. This is going in just in detail. You can see the ease of use of using the iPad. So this is another example of a 3D image, and you can see the different colors representing the different objects, and also how easy it is to view the objects in 3 dimensions. And as well as marking, as I mentioned, directly on the concrete, there's also a traceable record of what has been detected thanks to the use of the iPad. Here you can see another video of the GPA 1100 in use on quite a large area. So here the grid has been marked out on a piece of fabric, so that's reusable, so much quicker than having to draw it out each time. And you can see once again a good example of a 3D image with the GPA 1100 grid scan. And this once again is an example of this super line. So seeing one sweep using the GPR array. So that's the conclusion for GPR. But before we end the webinar, I'd also like to share with you some complementary technologies. So there are some instances where GPR cannot be used for hit prevention. So the three complementary technologies are Profimeter, GPR, and Pundit. So these use different technologies. So the first, for profometer, we use eddy current. GPR is electromagnetic waves, and Pundit is using ultrasonic waves. So you can see there graphically represented, the profometer is only good for rebar very close to the surface, so the first layer. With GPR, we can see deeper, and we can also detect other objects, for example, PT cables, as we showed previously. And finally, with ultrasound, we can see even deeper, so several meters, and this is more sensitive to air. So it can be used to detect rebar and other metallic or plastic objects, but it's particularly good for detecting voids or defects. So here are just some images of the instruments and what they can detect. So you can see profometer can only do rebar, so it can detect and even measure rebar, but that's all it can do. Whilst GPR is more versatile, and the Pundit array using ultrasound is mostly for defects. So comparing GPR with the cover meter, so our brand name is Profometer for this. So the cover meter uses eddy current technology. As I mentioned, it's used for the top rebar mostly. And what it's predominantly used for is for measuring the cover. So this is measuring the thickness of the concrete from the surface to the top of the first layer of rebar. And it's also the only device that can estimate the rebar diameter itself. So you can check the rebar grade that has been used. And then complementary to this is GPR, which uses electromagnetic waves and is an imaging technique. And we can see the second and even more layers of rebar. We can also see other structural elements such as PT cables, also conduits. We can get an estimation of the slab thickness and sometimes even detect voids within the concrete. So you can see here the cover meters can do measurement of rebar very well, but that's all they can do, whereas GPR is more versatile. Now we'll look at some examples for ultrasonic pulse echo. So this is an example of a beam which has many rebar, closely spaced rebar, and also an I-beam, so a metallic I-beam in the center. And the Pundit array, so ultrasonic pulse echo imaging, was used. You can see some features here in the image. So this 90 centimeters is the total thickness of the concrete. So quite thick, thicker than what we'd probably be able to see with GPR. But here we could see right through to the back of the slab. We can also see the rebar, and later we'll look at these in detail. And then here you can see 3 points which indicate the position of that I-beam. So the 2 points and then the flat part in the center. And here, if we look a bit closely at the rebar, here they're actually very closely spaced. But with the ultrasonic technology, we were able to resolve them. And this is probably something that would not have been possible if we had just used GPR. So another very common application where we use ultrasonic pulse echo for hit prevention is for steel fiber reinforced concrete. So this, as you probably know, is concrete which has very small steel fibers distributed throughout the concrete. And because the electromagnetic waves are reflected so strongly from metal, GPR doesn't perform well at all on this concrete because the results will be very fuzzy, very blurred, because the metal inside the concrete just reflects the electromagnetic wave too much. So here I'll show a video. of the ultrasound array, our Pundit array, being used to check for structural elements in a slab. So this was an industrial building where they were going to install some machinery. So they needed to obviously avoid the structural elements, but they couldn't use GPR because it was steel fiber reinforced concrete. So instead, I just play it again, you can see they used the ultrasonic array. And here very clearly you can see the back of the slab and the objects in between, and the metals, so the steel fibers, don't distort the image. Whilst with GPR, the image would definitely not be this clear. And a bit more detail about this SFRC inspection. So this was a study that was done on 3 different concrete blocks, all the same thickness. One of them had no steel fibers inside. One had a high fiber content of 60 kilogram per cubic meter. And then the third block had less fiber content. And you can see here are the ultrasonic results for a plastic tube inside these slabs. And you can see the results all look quite similar, which shows how the ultrasound was not affected by the steel fibers. If you look carefully, you can see that the velocity of the ultrasound was affected by the steel fibers, so the speed at which it propagated. But in terms of the image quality and being able to detect the plastic tube, the ultrasound performed very well. And this is an example of a rebar. So again, there's 3 different blocks with different amounts of steel fiber, and we can pick out the rebar very well. But once again, the velocity, we need to be mindful that the velocity is affected. So that brings me to the end of the presentation. We'll now answer any questions that have been entered into the Q&A box. I'd just like to launch one more poll asking if you'd like any more information about the products which we've described today. So the ProSec GPR family of products, the Pundit ultrasonic pulse echo, and our cover meters called Profimeter. On our final slide, we'd like to share our contact details in case you have any further questions or comments after the webinar. And also, if you visit our website, screeningeagle.com, we have an inspection space, which is a wiki where we share different examples, different case studies. You can see here, for example, the SFRC inspection is detailed on our inspection space. So please do visit to find out more.